My name is Deniz Uzgarapaydın. I'm taking Physics 102 in Section 9, and this is my lab report video. Now, my lab report was originally going to be about the magnetic field produced by a current-carrying wire, but that wasn't nearly high enough to be detected by the Gauss meters we had in the lab, so I'm using a solenoid instead. And the lab has an 800 turn solenoid as well as 2 and 400 turn variants, but I need the highest for the highest values. And 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 the Gauss meter has a precision of 0.1 Gauss. The lowest value I found was 3.0, so that's good enough. So that's good enough. Either way, I put the DC power supply on the solenoid and start it. I mean, I just start the solenoid and start the power supply and measure the current and the magnetic field inside. But after doing that, it's important to recalibrate the Gauss meter because otherwise it might get decalibrated from all the changes in magnetic fields. These calibrations also take care of the Earth's magnetic field, which at 0.5 Gauss would be very much noticeable. Either way, then I needed to find the dimensions of the solenoid so I could calculate the resistivity of the material it's made of, which I presume to be copper. Then I found that its diameter was 0.45 millimeters on the vendor's website. I also calculated its sides and corner length, which I'm saying that because it's rounded like this, like a rectangle but with rounded edges, which turned out to be about 10% off from the theoretical resistivity of copper, which could be explained by the imprecision of the ruler and as well as other imprecisions, 13%. Or either way, the resistivity was close enough to copper that it's remained within our error values. But it would be interesting to do this experiment with a higher precision measurement method. It would be hard to use a caliper because, well, I thought of using a caliper, but it would only give me a precision of like. I thought of using a caliper, but it would just. I don't think I could measure the circles with corners with it. I couldn't measure the corners with the caliper, and that was the main source of error anyway. So it wouldn't help that much to use a caliper. Either way, and I also used this experiment to demonstrate Ohm's law, but that's pretty elementary, as well as the relation between current and the magnetic field of the sun, which, of course, is proportional. Thank you and goodbye.